Hey everyone, and welcome back to the channel. Today, we're diving deep into a fundamental concept every developer and IT professional working with Linux needs to master: file permissions. Think of file permissions as the digital gatekeepers of your Linux system. They dictate who can read, write, or execute your files and directories, ensuring security and proper access control. Neglecting them can lead to security vulnerabilities, frustrating errors, or even system instability. But fear not. By the end of this video, you'll have a crystal clear understanding of RWX permissions, ownership, and how to effectively use commands like ls, l, chmod, and chown to manage them. We'll even explore how to handle permissions for multiple files at once. Ready to unlock the secrets of Linux file security? Let's get started. First, let's break down the core of Linux permissions, the RWX triad. These three little letters, R for read, W for write, and X for execute, are the building blocks of all file access. For a regular file, R means you can view its contents, like reading a book. W allows you to modify or delete the file, much like writing on or erasing a whiteboard. And X is crucial for executable scripts or programs. It means you can run the file, just like pressing a play button on an application. But here's where it gets interesting. For directories, RWX take on slightly different meanings. Read, R, allows you to list the directory's contents, seeing what files are inside. Write, W, lets you create, delete, or rename files within that directory. And execute, X, for a directory means you can enter it, allowing you to navigate through its structure. Without X permission on a directory, you can't even cd into it, even if you have read permission. This distinction is vital for understanding why certain commands might fail. Now that we understand what R, W, and X mean, let's talk about who gets these permissions. Linux categorizes users into three distinct groups when it comes to file access: the user, that's you, the owner of the file, the group, and others. Every file and directory on a Linux system is owned by a specific user and belongs to a specific group. The user is typically the person who created the file. The group is a collection of users who share common access rights to certain files. Think of it like a team project where all team members need specific access. Finally, others refers to everyone else on the system who isn't the owner and isn't part of the owning group. This tripartite system provides a highly flexible and granular way to manage access, allowing you to set different permission levels for individuals, teams, and the general public on your system. This layered approach is fundamental to Linux security. So, how do we actually see these permissions in action? This is where the powerful ls-l command comes in. When you type ls-l in your terminal, it provides a long listing of files and directories, including their permissions. The first character of the output tells you the file type, a -dash for a regular file, a D for a directory, or an L for a symbolic link. Following that are 9 characters, divided into 3 sets of 3. These represent the RWX permissions for the user, owner, then the group, and finally others. For instance, RWRR means it's a regular file, the owner has read and write access, the group has only read access, and others also have only read access. Or, DRWXRXRX means it's a directory, the owner has full read, write, and execute permissions, while the group and others can read and execute, meaning they can list contents and enter the directory, but cannot modify files within it. Understanding this string is your key to immediately knowing who can do what with a file or directory. With a clear understanding of what permissions are and how to view them, let's learn how to change them using the chmod command. Chmod stands for change mode, and it's your go-to tool for modifying file permissions. There are 2 primary ways to use chmod: symbolic mode and numeric or octal mode. Let's start with symbolic mode, which uses letters and operators. You specify the user category, U for user, G for group, O for others, A for all, followed by an operator, plus to add permission, dash to remove, or equals to set specific permissions, and then the permission itself, R, W, or X. For example, to make a script executable for the owner, you'd use chmod u plus x my_script.sh. To remove write permission for others from a sensitive file, you type chmod ow private_data.conf. Or, to precisely set read and write for the group, and no permissions for others, you'd use chmod g equals rw, o equals file.conf. Symbolic mode is highly intuitive and great for incremental changes to permissions. Now, let's explore chmod s numeric, or octal, mode. This method is often preferred for setting absolute permission values, as it's more concise once you grasp the underlying logic. Each permission, read, write, and execute, is assigned a numerical value, read is 4, write is 2, and execute is 1. To determine the octal number for a set of permissions, user, group, or others, you simply sum the values of the permissions you want to grant. For instance, rwx, read plus write plus execute, would be 4 plus 2 plus 1 is equal to 7. rw-, read plus write, is 4 plus 2 plus 0 is equal to 6. rx, read plus execute, is 4 plus 0 plus 1 is equal to 5. So, if you want your script to be executable by the owner, readable and executable by the group and others, a common setting for scripts and programs, you'd use chmod 755 my_script.sh. This translates to rwx for the user, 7, rx for the group, 5, and rx for others, 5. For a file that only the owner can read and write, you'd use chmod 600 private_data.conf. Numeric mode is powerful for quickly setting precise permission sets. Beyond just who can do what with a file, there's the question of who owns the file. This is where the chown command comes into play. Chown stands for change owner, and it allows you to modify the owner user and/or the owner group of a file or directory. This command is particularly useful in multi-user environments, when moving files between users, or after a file has been created by a root process and needs to be handed over to a less privileged user. It's important to note that changing ownership typically requires superuser privileges, meaning you'll often need to preface chown with sudo. To change only the user owner of a file, you'd use sudo chown new user file.txt. To change only the group owner, it's sudo chown new group file.txt. And to change both the user and the group at once, you combine them, sudo chown new user new group file.txt. Just like chmod, chown also supports the recursive option, allowing you to change ownership of a directory and all its contents with a single command. Be careful with as it affects many files. Managing permissions for individual files is essential, but what if you have dozens, hundreds, or even thousands of files that need similar permission adjustments? Manually running chmod or chown for each one would be a nightmare. This is where batch operations become incredibly powerful. Linux provides several ways to apply permissions to multiple files efficiently. You can use shell wildcards, also known as globbing, for simple patterns, like chmod u plus x star.sh to make all shell scripts in the current directory executable for the owner. For more complex scenarios, the find command combined with the exec option is your best friend. For example, find. Type f, name, star.txt, exec chmod ow, // grave accent will find all files ending in .txt within the current directory and its subdirectories, then remove write permission for others from each of them. This allows for highly targeted and automated permission management across large file systems, saving you immense time and reducing the risk of human error. Understanding and managing file permissions isn't just a theoretical exercise, it has very real implications for the security and functionality of your Linux systems. Incorrect permissions are a common source of errors, leading to permission denied messages when you try to run a script or access a file. They can also create significant security vulnerabilities if sensitive data files are readable or writable by others, or if critical system files are writable by unprivileged users. Best practices include always giving the least necessary permissions, the principle of least privilege, ensuring your executable scripts actually have execute permissions, and being mindful of default mask settings which dictate the default permissions new files and directories get. Regularly auditing your file permissions, especially for critical directories like web servers or database files, is a good habit. Proper permission management is a cornerstone of a robust and secure Linux environment. And there you have it. A comprehensive journey through Linux file permissions. We've demystified the RWX triad, explored the concepts of user, group, and others, mastered viewing